Hello.
How's it going?
Good. How are you?
I'm doing okay. I'm gonna let you know right now that I just got out of a GSG session with another group, and my internet was a little wonky towards the end of it there.
Okay.
So if I disappear, I'll do my best to get back on like ASAP. But I'm not really sure what's happening with my internet at the moment.
No worries.
I'm hoping it doesn't happen again. But this week we were doing sections 4.5, 4.6, 4.7, and 4.8, right?
Yes.
I.e., a lot of like just applications of this type of stuff, logistic growth, surge functions, and averages. Do you want to just jump in and do a couple problems?
Yeah, this is probably the first week that I've just gone, oh my God, because I don't know, I'm having such a difficulty with 4.5 that it's hard to move on from this because it's all that I think about. I just don't understand.
Oh, okay. Well, we can definitely get that fixed. Well, we can try our darndest to get that fixed. Let's do question 2 in 4.5, which for me has a graph that shows Q is equal to 10,000 and then has several sections. A, find the average cost when production level is 10,000 units. We're just going to start find average cost. I'm not going to write that all out. B is represent graphically. And C is going to be at approximately what production level is average cost minimized. Okay, so I'm going to sketch out the graph. It's not going to be the prettiest thing in the world. I'm sorry, but
That's okay. I've got my copy here.
Oh, awesome. Basically, there is this big old graph. Here we have the graph C. So C, Q. And right here is 10,000. Here is Q. And there is dollars. This is, let's see, that's 10,000, 12, 14, 16. Is that how it's set up? Nope. That's just over 15,000. Here is 15,000, and here is, this will be 17.5 thousand. Okay. So we need to find the average cost when the production level is equal to 10,000. What does that mean?
I do know that average cost is C of Q over Q, and C of Q is the total cost, and then Q is the quantity, so it's the total cost divided by the quantity.
Awesome. So that's going to be per unit, right? The idea is that per unit, it's going to cost about this much. Thinking about it, like what if we had a line, right?
Mm-hmm.
That would basically say that we're incorporating our startup costs. So our average cost would not be like the slope of the line. In this case, it would incorporate the startup cost, so the average cost for all of the things that we're making. What does that look? Actually, that's part B. I was about to jump into what does this look like graphically, but that's part B. So our average cost is going to be what?
The way I interpreted it was right around, God, I don't know. So 1.25. So I estimated to be at 16.25, but the book has the answer of 16,000.
I would guess 16,000.
Yeah. And that divided by 10,000, which I believe is 2. No, wait. Oh my God. So that would be 1.6?
Yep. So 16,000, I'm just using K
Yeah.
as 1,000, if that's okay.
Yeah.
Divided by 10,000, this is going to end up equaling 1.6. So that's A of Q, I believe is how we're going to say that. A of Q. Okie doke. What does that look like graphically?
I have no idea.
What did we just do? We have this point that is 10,000, 16,000.
Yeah.
We said that our average cost is going to be equal to our C of Q over our Q. We're actually going to not call that dollars. I think it would be easier to understand this as the C axis. So now we have a function where we put in something and we put in items and we get out the cost, right?
Right.
So, does this is sort of like our Y, right? The C.
Yeah.
Divided by what is essentially our X. Can you think of anything else that kind of has Y over X or something similar?
That'd be the rate of change.
Yep. In this case, we're going to just say delta Y over delta X. But what must be the other point?
Would it be from the origin at 0, 0?
Yep. So we just said that our average cost is the slope of the line going from 0, 0 to the point. Flashback to that graph that I drew earlier, where I had a line that looked like this. Basically what we're saying, the average cost now is not the slope of this line, but the slope of this line, right? Because we're going from the origin to the point on the line. So that's like a simple version of it that kind of illustrates that what we're looking for is not the slope of the original line, but the slope of the line going from the origin to our point. So are we okay with setting this up graphically and with what the average cost kind of is?
Yeah, I'm good with that.
Um, so we've got that. We say the slope of this line is the average cost. Um, our next part of the question, though, is at what production level is the average cost minimized? So what is this question asking? Start with production level.
Um, I think I know the answer.
Fine.
I think it's when the line, the average cost line, which is that green line, the
Mm-hmm.
slope of that line meets up to the cost function, which is the marginal cost. So it's when those two, I guess the slopes join is when it would be, I guess when it would be minimized. The average cost is minimized.
Essentially, yeah. Yeah. So this is the way that this question is kind of situated is we're asking at what Q, at what amount of stuff are we making? Is the average cost minimized? And then when we say minimized, we're saying A of Q is going to be sort of like aligned with or like aligned perhaps. A of Q is going to be at its lowest. It's going to be minimized. And that is, visually speaking, when it's kind of aligned. How are we thinking about doing that, though?
I'm not really.
Yeah, I'm not sure what this question is asking. Like, do they want you to graph it? No, they want the Q value at which that is the case.
It's got the answer of Q is approximately 18,000. So I'm assuming that it's just asking for us to look and see approximately
I
the Q
guess,
value.
yeah. That's okay. So the idea would then be that this would be the place, right? Um, just visually speaking, if I go all the way up here, and yeah, that would come out to be about 18,000. That would be the location for this to happen. We can think about other spots on this graph, right?
Yes.
We can kind of estimate other spots on this graph. But do you see how the slope for all of these is greater than the slope of the orange?
Yeah. I think I was reading way too much into that
Yeah.
question. I didn't realize how basic it was.
We're basically just like, what is the lowest slope that we can make? And it is going to be set up. Okay. So there's question number 2. Let's next do question number 4.
Okay.
Where we have the cost of producing Q items is C of Q is equal to 2,500 plus 12Q dollars. What is the marginal cost of producing the 100th item and the 1,000th item? And then what is the average cost of producing 100 items and 1,000 items?
So the marginal cost of the 100th item, I believe we're just replacing Q with 100 to find what the marginal cost would be.
You want to set it up like so.
Yes.
Okay. What is marginal cost?
The total cost of producing an item?
That is cost.
Okay. Marginal cost is the cost of producing an additional item over and above a certain quantity.
Yes. In math terms, what is marginal cost? Every time I see marginal cost, I just change it immediately to something else, which is what?
I don't know.
The derivative of C.
Okay.
Marginal cost is just the rate of change of C, and they have that definition saying that when we're going from one more, in order to specify, the marginal cost at 100 is going to be taking us from 100 to 101 items, and we want to analyze how it changes from here to here. But essentially what that is we have the derivative, and we're going to use it. So
Okay.
if marginal cost is the derivative of cost, then what is the marginal cost producing the 100th item?
12?
Yes. And what is the marginal cost of producing the 1000th item?
Would it be 12?
Yep. We're looking at a line, right? This is a line that is set up like so. We've got our y-intercept of 2500, and we've got a line with a slope of 12. Right? So this
Okay.
is our C of Q. If I gave you this and I asked you to draw me this derivative, what would it look like?
Would it start from the origin of
Nope.
0? No?
No, this is back to section 2.2 or something,
Okay.
where if I give you the original function, that looks like a line. How do I draw the derivative? How do I draw the rate of change?
Oh, so that's positive.
Mm-hmm.
So it would be above the x-axis because it's positive and it doesn't have any zeros, so it's just continuous.
Mm-hmm. What would it look like? Does the rate of change change?
No, it stays constant, so it would be flat all the way across.
And what is this number?
At 12.
Yep. So now can you see why at 100 and at 1000 items, why the marginal cost, which is the derivative, is equal to 12 both times?
Yes, I can completely see that now.
For sure. You got this. You have all of these tools. You know what's going on, I promise. Okay. So we now have our marginal cost set up. I left this here in the green because we're going to still use this to find our next question, which is the average cost.
Average cost.
Yeah.
So the average cost, that whole thing would be over 1,000, wouldn't it?
This is of 100 right now.
Oh, that's of 100. Okay.
I clearly don't know what zeros are. I wrote an extra zero there.
Okay, I just want to make sure.
Yep.
Okay, so then that would be over 100. So that would be
3, right? 12 times 100. So, and then I'm also going to go ahead and find just the cost of having 1,000 items. This is kind of what I'm starting with. So this is 2,500 plus 12 times 1,000. So that's 12,000 plus 2,500 is 14,500. So now if I need to find the average cost, I can go ahead and do it like so. I have my average cost of 100 is going to be C of 100 over 100, which is going to be 3,700 over 100. Cross those off and get 37.
Okay, I see how you set that up.
Now you walk me through what I'm going through over here.
It's I believe it's the total cost that's over the quantity, and then you're just doing simple algebra.
So I've got 14,000 over 1,000.
That's 14.5.
Okay. Now there are no more questions here, but we're going to kind of think about what we have and what it kind of means. So why is the marginal, or not the marginal, excuse me, why is the average cost greater at 100 than it is at 1,000?
Because there's less units produced, so you can't spread the average cost. Well, if you spread the average cost over a smaller number of units, it's going to be higher per unit than if you produced a higher number of units that you could spread that average cost over.
Basically, yeah. And it's mostly the startup costs that we're like looking at here. That $2,500 gets spread out much better on the yellow line or on the green line than it does on the yellow line, right?
Yeah.
Because we have more items, so the average cost gets incorporated into more, like the startup costs get incorporated into more items. Startup cost being this at 0, I'm still in for $2,500 essentially. But let's compare this to the marginal cost, which equals 12 at all times. Both of these have average costs that are greater than the marginal cost. I don't actually know where I was going with this statement. I'm not really sure. If this was
okay.
like not a line, we could make some more inferences, I think, off of it. But because it's a line, we're pretty much, this is what's happening. I don't usually spend a ton of time on this section. Usually people are like jumping into logistic and surge functions. So this is, yeah. Okay. Let's do question 8. Yes.
I'm sorry. What threw me off was a critical point and then the local minimum or maximum. The critical point, I got so confused. I watched his lecture. I attended his lecture, and then I watched it many times, and it just confused the heck out of me when I'm trying to compare his lecture to what it's asking in the book, where it's saying, at what production level does a average cost have a critical point? And then is there a critical point? Is the critical point a local maximum or minimum? And I think I understand the average cost is a critical point, is that we're just, because it's the numerator that we're taking, not the whole thing, right?
Yes. Actually, I'm pretty sure that's what you're working. Like, tried to follow that. I'm glad that your chain of logic made sense to you. I might have to ask you to repeat it, just for my sake to follow along.
Yeah, it makes sense to me, but trying to get it out there, just probably not the easiest thing to do.
Okay. The critical points of average cost. What are we like?
In my book, it's question 7. It's C of Q equals 0.1 Q squared plus 1,000.
I have a very similar question, I think, but not quite the same. Um, repeat to me what your question is.
Um, at what production level does the average cost have a critical point, and then is it a maximum or a minimum? And I remember the first and then second derivative test, but trying to apply it to this when it says average cost is just, it's throwing me.
Okay, so what is the equation for average cost that they gave you?
Average cost is C of Q over Q.
Or did they give you an equation? We might have different
Oh,
problems.
yeah, 0.1 Q squared plus 1,000.
I don't have this exact problem, but the problem asks you to, this is question 7 for you in the 6, and it is asking you to find the critical points
Mm-hmm.
and
If it's a local minimum or maximum.
basically how I would think about this to start with is they gave you an equation, they called it A of Q. If all they're asking you to do is find the critical points, then don't get bogged down too much in like the nitty gritty of it.
Okay. So it's just the same as before, just finding
Yeah,
the derivative, which I have the derivative as 0.2 Q.
yeah,
And then it has to be set to 0 to find a critical point.
yep.
And then that's kind of where I got lost because if I divided both sides by 0.2, then it just gave me Q equals 0.
Yep.
Oh, that is right.
Our critical point is when Q is equal to 0.
Okay.
Yep.
And then is it a local minimum or a local maximum or neither? And then I would just take points on either side of 0, which would easily be -1 and 1, and just plug it into Q and see what the sign is.
Okay, so here we have our 0, -1, and 1. Um,
So then it would,
yeah, go ahead.
oh,
Sorry.
sorry, no. Sorry, I'm just thinking out loud. If it was -1, then the sign would be negative, so it would be decreasing, and then at 0 to the right of it, positive times positive is positive sign, so that would be a local minimum. So I do know this, I'm just,
Yeah.
okay.
What would this look like?
That would be just a parabola opening up by probably x squared. Oh, it is q squared. Okay. And it's 0.1.
Um, our y-intercept is actually going to be, if we plug in q
Mm-hmm.
is equal to 0, our y-intercept is going to be 1,000. This is 1,000. We really only are looking at the average cost of positive quantities. So I'm not going to draw into this negative quadrant over here.
Mm-hmm.
And this is our function, A of Q.
Okay. All right. I'm feeling better now. I'm feeling a lot better.
Yep. I promise you, you know all of this. Um,
Sorry to hijack.
no, go ahead.
If you want to continue on with what you were saying before about what you usually run over with this section.
Oh, I was just going to hop in and do another problem.
Oh
One that
yeah,
I know
no.
that I've, done before, I guess. Again, I was saying that most people like jump into 4.7 and 4.8 more so. So I don't usually spend a ton of time on this section.
Mm-hmm.
So it's very interesting for me to actually like engage with this material
Ah,
here
okay.
because it always gets lumped in with the surge and the logistic functions, and that's usually what drives people nuts.
is is that they don't take the time to kind of get the basics down, so when they move on to more advanced stuff that it's just more difficult.
Yeah, logistic function and surge function just get people, I think. I think the search function is really cool. I guess I'm a like microbiome biochem person, so
Yeah.
search functions is like really cool for me, and logistic functions too. I mean, both of those are just very useful in my field, so I love doing them. But they
If I
drive
can
people bonkers.
if I can communicate it to people and understanding
Hmm.
what a logistics function is, they can understand it. And if not, but you find that most people just don't really have a knack for that kind of stuff. They just kind of deal with just about everything else but that type of stuff. So it's really
Yeah,
hard to get them to conceptually understand that you start off slow and then you build exponentially and then you relax again in terms of your growth and then you just keep going through that cycle.
yeah. I always love to use. I learned about logistic functions. I know we're kind of going off the rails here, but I learned about logistic functions in the context of population, which just makes a lot of sense to me.
Hmm.
Um, because like if you have very few like deer in a park, they're going to replicate very slowly at first, but they are going to increase, and the more deer you have, the faster they increase, and eventually you hit like a point where you're at like a carrying capacity, and the deer aren't going to have any more food to eat, and it just like it makes a lot of sense to me to like think about that way.
I
Um,
I do the same thing, but with business where like my wife graduated a couple years ago with her MBA in human resources and she's doing her consulting business, but it's very slow in the beginning. And then, now that she's been doing it for a couple of years, it's slowly starting to increase. And eventually she'll hit a point where it's just a exponential growth and then she'll slow down until she starts to make different changes to prepare for growth again.
yep. So very fun functions, but
Yeah.
not average cost, which is a problem that we're going to do right now.
Hmm.
You are the manager of a firm that produces slippers. They sell for $20 a pair. You are producing 1,200 pairs of slippers each month.
And an average cost of $2, and the marginal cost at a production level of 1,200 is $3 a pair.
Yep.
So this one kind of threw me off. I just wrote the variables down, but I didn't actually get to it, understanding how to calculate it.
And you're selling them for okay. Are you making or losing money?
Um,
How can you tell if you're making or losing money?
that's a good question. I I think it's a
If you're
marginal
making money, what are you making? What's like a word for that? For
profit.
yes. So say I have a function for profit, P of Q. How can I represent profit in terms of two things that we know and love, two things that we love to work with?
Um,
I have what I'm selling for, and I have production.
so number of units and price. No.
That's that's like essentially it. What I'm going for is cost and revenue, and it's minus cost. So I've got revenue minus my cost, right? So however much money I make selling these minus however much money I spent making them is going to be my profit. Simply. I know I orchestrated, I set up as minus C of Q minus R plus R, but I hope that that's kind of visible.
Well, Okay. So this is
Are you okay with this? I can rearrange it.
yeah. No, 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 no. That's fine. Yeah, I saw the minus sign in front of it.
Oh, I erased it anyway. So, this is going to be revenue minus cost. So I'm looking at right now. I am making 1,200 pairs a month. So I'm looking for. The question is, am I making or losing money? So I'm looking to see what my profit is at 1,200 pairs a month. So this month, do I make a profit or not? That would require me to get the revenue 1,200 minus the cost.
That's where I made the mistake, is I was looking too much at marginal cost at a production level of 1,200 is $3. But if the average cost is $2 per shoe, then it would be $2 times 1,200, which would give me what the average cost is. And then if I'm selling it at $20 a pair, 20 times 1,200, and then subtract the two numbers, which would tell me if I'm making money or not.
Mhm. It doesn't really tell you if you sell all of them.
Oh, okay.
I'm gonna assume you do because it doesn't say that you don't, and there's no way to determine. Is there a way to determine? This is how I set up a problem, and I've definitely done this problem before, but sorry, I guess it's been a semester. I guess I'm going to make the assumption that you do indeed sell all of them. And we'll see. That's $20 per pair and 1,200 slippers. Very obviously, you are going to be making a profit. Oh, I crossed that out. I meant to underline it.
Yep. According to the answer key, it does just make that assumption. So $24,000 for total
Awesome.
profit.
Okay. So we are indeed making a profit. We're making money. Will increasing production increase or decrease your average cost? And then will it increase or decrease your profit? This brings into where we were between how do average cost and marginal cost, like how are they related? So go ahead.
Oh, sorry, I didn't mean to.
Go ahead.
I was just going to say, it's only when marginal cost equals average cost are you making a profit? Or that's not, is that right?
Okay. So there's a point where marginal cost will be equal to average cost, right?
Mm-hmm.
We call that the critical point.
Okay.
So whatever Q equals when this is the case. And I'm going to change that from marginal cost to C prime of Q. So whatever Q that this is true at is a critical point. Then on either side, we have if C prime of Q is greater than average cost. And then we have the condition if C prime of Q is less than average cost. And this will tell you if increasing production will increase or decrease average cost. So if marginal cost is less than the average cost, then this will then increasing production. So greater Q will decrease average cost.
Okay, so it's just asking the simple question of what do you do if average cost is greater than marginal cost or marginal cost is greater than average cost?
Yes. So again, if Q continues to grow, then the increased production, in this case, if marginal cost is greater than average cost, it will increase the average cost. So the idea being is that I'm trying to think of a function that will give us a good visual here. I'm thinking about just going back to something that looks a little bit like this. Here is our marginal cost, right?
Mm-hmm.
Something that looks like that. And then our average cost is going to be something that looks like this. So here, our average cost is greater than our marginal cost. So if I increase my production, so if I move over here, it will decrease my average cost. Oh, I haven't already used. So this is my increase in production. So Q gets larger. And then how is my slope compared? Are you kind of following this?
Yeah, the slope of the marginal cost and the slope of the average cost. Yeah, it's just like what he was describing in the lecture that he had Tuesday.
So continues to get like smaller. What if instead of being there, I was here? So my average cost is going to be like so. My marginal cost is going to be like so. So increasing it is going to bring me to a slope of an average cost that is higher than what it initially was. So that's kind of graphically representing these relationships right here. Does that make sense? Are we like cool?
Yeah,
okay.
Yeah, that makes sense.
So based off of the information that we have here, which is greater, marginal cost or average cost?
Marginal cost is just the cost of production, which is over and above what it is that you're making. So it's asking increasing production or decreasing. So that $3 per pair is in addition to what the average cost is. So that would be $5 a pair. No?
Not quite. What is marginal cost? It is C prime of Q. So this is how our cost function is changing. So if I were to go from 1,200 to 1,201 pairs, right?
Oh, so it's just an additional $3 per unit. It's not.
Yeah.
Oh, so if you produce an extra 2 pair, that would be an extra $6. If you did 3 pairs, then it would be an extra $9.
Essentially. The reason we specify right here is that we don't want to really go out too far. We don't want to say if we make another 100, it's going to cost us $300 because that might not be what the function says. And that's why we call it C prime and not, like marginal cost all the time. But yes, in principle, yes.
And that's why it's the prime, it's the slope, it's the rate of change, which is just $3 a pair.
Yeah.
So then it would just be So that's added onto what the cost is already. The marginal cost is added to whatever the cost is.
If we're going from 1200 to 1201, but are we doing that?
I don't know. It just says, will increasing production increase or decrease your average cost?
So let's just look. We can tell if average cost will increase or decrease based off of a relationship between marginal cost, or C prime of Q, and average cost, right?
Mm-hmm.
So let's just set up and compare our average cost and our marginal cost. So here's our marginal cost at $3 a pair. Here's our average cost at $2 per pair. Which is greater?
The marginal cost is greater.
So if average cost is less than C prime of Q, or rather if C prime is greater than A, then what does that mean?
I have it written down. So increasing production increases the average cost? But then what would that do to profit?
Let's go back to what we're looking at for profit. Profit is revenue minus cost. What will the change in profit be if my costs increase?
The change, it would decrease profit. Well, I mean, you'd still be making, well, what is the definition? Because I mean, before the profit was, where is it? I know it was positive. What was it? It was.
We didn't find a direct number. We just wanted to know if it was positive or if it was negative.
Mm-hmm. So if you're making, let's say $13 profit, and then you increase production, and then it drops it from $13 to $8, is that still an increase in profit or a decrease in profit? Oh, it's still positive.
It's still positive. It's like if we have a negative rate of change and it's all still positive. We're allowed to do that. We're allowed to have a decrease, a negative rate of change, and still have the numbers be positive.
Oh, I guess from a business perspective, I wouldn't understand why I would reduce my overall profit per unit just to increase production.
The idea is that the units cost more now,
Mm-hmm.
and thus, but we're selling them at the same price. So if our costs go up and our revenue doesn't change, then our profits are going to change and decrease with respect to what they once were.
But it's still a positive profit, so it's
You're
still
still making,
increasing.
yeah, you're still making a profit. It's just not as much of a profit as you were making previously per unit.
Gotcha.
Because we are only looking at this, like, how much profit are you making per unit, essentially.
That makes sense.
So our units for all of the profit, revenue, and cost are essentially going to be like per unit, I believe. Because we kind of established that this is going to be our well, it's going to be dollars, but it's going to be taking into account how many units that we're selling. And in this case, we're selling 1,200 units. And we just
That makes sense.
For this whole bit there. Okay.
Okay.
So, are you okay with saying that increasing production increases the average cost?
Yes.
Are you okay with saying that increasing production decreases our profit, even though the profit is still positive?
Say that again?
Increasing production
Mm-hmm.
increases our average cost.
Mm-hmm.
If our average costs increase and our revenue doesn't change, then our production or our profit is going to decrease relative to what it once was.
Okay. I'm good with that.
Okay. C, would you recommend that production be increased or decreased?
I would recommend that it would be increased because we're still making money while we're doing it. Not making as much money, but we're still making money.
I'm not sure that's the answer that they want you to give. I think the idea is that you want to maximize your profit function. So if you want to make as much profit you can as you can per unit, I think that's what they're going for. But you get what's going on here. I don't know if I would agree with that statement. Just
It
because
it says yeah. It says that we recommend increasing production since that increases profit, which I mean, I guess overall profit it would because you're selling more units, so you're making more
yeah,
money that way. The fact that the average cost of production increases is irrelevant to your decision. Okay. So making money is just making money. It doesn't matter.
okay, I guess.
Yeah, I
I
would
don't know
be.
anything about business, unfortunately.
Yeah,
Business is not my what is money? I don't know.
I would stop.
We can prove that if you'd like. We can go through and show that the profit for making 1200 versus the profit for making 1201.
Yeah, you're just selling more units and you're making less per unit, but you're still turning a profit. So you just want to keep going because it costs a lot of money to stop production. Boy, does it cost a
Yes.
lot of money to stop production.
Yes.
Okay, I'm cool with that. I'm cool with this section.
Okay.
Oh, thank you so much.
Yeah, for sure. I'm glad you feel better about it. I promise
um,
you, this is all stuff that you know, and you've engaged with before. It's just I don't really like how it's framed. I'm not a huge fan, but you know,
it is
sometimes
what
we gotta
it
learn
is.
things that are not kind of expressed in the most, you know,
The easiest way,
way.
clearest way. Yeah.
Okay. Unfortunately, I do have to go at 4:30.
Okay.
Um, but that does leave us time for one more problem.
Okay. Do you want to pick something from a different section?
Would you like to pick something from a different section?
I actually, honestly, in all honesty, I haven't gotten that far yet because I was so focused on this section and trying to understand this before I moved on because I knew somewhere down the line, if I didn't learn this, it would cost me dearly. So,
Would you like to do a surge function question?
yeah, I haven't gotten there yet, but I'm sure I'll need to know it in the next few hours.
Okay.
So, a surge function.
Yes. Do you have, for me, it is question 8. It is if it is T minutes since the drug was administered, the concentration C of T in nanograms per mil of a drug in a patient's bloodstream is given by an equation.
Yeah, the function C equals ATE to the negative BT.
It is of that form, yes.
I think I have that.
So that form that you just said,
Mm-hmm.
C is equal to ATE to the negative BT, is going to give us a surge function, essentially, which looks like this. And the idea is that initially it will be increasing very rapidly. It will reach a maximum, in this case, concentration.
Mm-hmm.
And the time at which that happens is going to be 1 over B. So this is used a lot for like thinking about like drugs in a system.
Mm-hmm.
Um, so there's our function. Um, there is our time of peak concentration. I'm going to give us, for me, it's problem 8, where we are given the function c of t is equal to 20 t e to the minus 0.03 t. And this is measured in nanograms per mil.
Is this your problem? The one that shows in your book? I just want to make sure I'm following.
Yeah.
Oh, there it is. Okay.
This is the
20
one.
TE to the negative 0. Okay.
Awesome.
There it is. It's given by how long does it take for the drug to reach peak concentration? What is peak concentration?
Yes. Okay. Awesome. So, how long does it take for the drug to reach peak concentration?
Is this the product rule?
Not right now.
Okay.
Peak concentration happens at time 1 over b. What is b? Based off of this equation and this equation being of the same form.
What the question was?
How long does it take for the drug to reach peak concentration?
Okay. And you were asking what was?
What is b, essentially?
So that would be 1 over negative 0.03?
Very, very close. The negative is along for the ride. So b is just going to be 0. Which makes sense too, because we're looking at a time, and we're not going to have negative time. So this is going to be 1 over 3 over 100, or 100 over 3, or approximately 33.3.
That 3, so
1 over b, sorry.
That's okay. The 0.03 in the denominator, is that always times 100 to get a standalone?
Yeah, so 0.03 is 3/100ths, so like that's like 1/10. So 0.001 is 100th.
Okay.
Yeah, it's just kind of a metric to convert between decimals and
Yikes.
fractions. You could also plug into a calculator 1 over 0.03, and it should give you this. Okay, so we said peak concentration happens at time is equal to 1 over b. We said we know what b is. 1 over b is going to be equal to 33.3.
Mm-hmm.
What are my units here? It's just basically in the first sentence of the problem.
Oh, minutes?
Mm-hmm. Okay. What is the peak concentration? How do we find concentration based off of this equation? What is the equation of?
C of t?
Mm-hmm. So we have a time, 33.33 minutes, and we have a function where if we plug in time, we get concentration.
Okay.
So C of 33.33 is going to be our answer. So that's going to be 3 over 100 times 33.33. So that'll be essentially, we'll call this 60 is it? 600? Sorry, I do have it in my brain. Always struggle with that. It is 666.
66.6.
And that is going to be minus 99.99 over 100, so minus 1. So this is going to be equal to e to the minus 1, which is going to be 245.25. And what is my units here?
Milligrams?
Not quite. They give it to us right here.
Milliliters?
It's going to be nanograms per mil.
And you solve that by doing e to the -1 first, and then whatever that is times the 666.6.
Yes.
Okay.
That's what I did. I actually just put the whole thing into my calculator. So e to the minus 1 is 0.367879, and that times 666.6 is yes, what I have here. And they give you the units that you're supposed to use for concentration. Concentration is going to be some mass over some volume. In this case, small mass over small volume. Okay. So now we have our concentration and we have our time of peak concentration. Our next okay, so part B is going to ask us what the concentration of the drug is in the body after 15 minutes and then after an hour. All we're going to do there is plug in 15 minutes is equal to T and 60 minutes is equal to T, and we're going to get our answer.
Is that the original formula that was given? We just plug it into there?
Yep. We're going to do part C because I'm running a little short on time. If the minimum effective concentration is 10 nanograms per microliter, when should the next dose be administered?
If the minimum effective concentration is 10, I don't know.
And what we want is going to be so we know what our concentration needs to be, and we need to find the time at which that happens. Does that make sense?
So when C is 10, which is the concentration, so I would just set the whole equation equal to 10?
That's what I would do.
And then solve it that way.
So 10 nanograms per mil is going to be 20 times T e to the minus 0.03 T. So it's a question of solving for T. Oh, I see what they want you to do here. They want you to use the graph. They want you to say that this is 33. They want you to find out what 15 and what 60 is. And then there's going to be some line at which you can draw that is 10. So this is the method that they want you to go through without finding. Doing the algebra for this is just not going to be possible. 0.5 is equal to T e to minus 0.03 T. We've got an issue in that we have T times e to the T. So it'll be really hard to get that t isolated and by itself. So what they want you to do instead is use the graph.
Uh,
Yeah, which is not something that I guess we could do real fast, but there's going to be that line essentially that exists that says this is 10. They have it kind of in your book drawn this way where they say this is 10. Only above this is it effective, and so our time for effectiveness is going to be between these times. This is the time that we want because that's when we want to add more, or just before that, essentially. So if we add more then we get another curve that looks like this. And the way that you do that is just by looking at the graph and estimating what that time is. And
it doesn't have a graph on my book.
The graph isn't given in the problem. You're supposed to kind of set it up by saying what is C of 15 and
Gotcha. Yeah, I never would have got that from reading the problem.
Yeah, I always forget. I do this every single year. I'm like, how on earth do they want you to solve this? And then I'm like, graph time. Unfortunately, I don't have time to do the graph tonight. I'm
Nope,
so
understood.
sorry.
No, that's okay.
I hope that you have a wonderful weekend and that now that you understand the whole average cost thing, you get the rest of it down pat. Yeah.
Okay. Well, thank you. I appreciate your time and thank you very much for your help. Have a good weekend.
Thank you so much for coming every week, by the way. I really do appreciate having somebody to talk to in these because otherwise it's just kind of me. And engaging with somebody is always awesome. So
I really appreciate your help. So I'm so very grateful because I don't think I could do the class without that little bit of extra help on Saturdays.
thank you. Thank you.
All right, I'll let you go because I know you have another class to teach.
Have a wonderful weekend.
All right, you too. Thank you very much.
Bye.
Bye-bye.